Let's look at quiz 2, Math 5A, Teach the Teacher. The first part, I actually called it question number 1, parts A, B, C, D. So the numbering is off, but you can see. And also, these problems are similar to yours, not necessarily precisely like yours, but you can look at the way I did these and figure out how the others should have been done. So the first part, I'll call it number 1 here, part A in your exam maybe. Find the derivative with respect to x of 5 times x. Okay, so the derivative of 5 times x, well, you can pull the constant number out into the front. So it's 5 times the derivative of x with respect to x, which is just 1. Derivative of x is 1. So it's 5 times the derivative of x, which is 1. It equals 5. And the explanation is here. Let's go to part 2. Find the derivative with respect to x of the square root of 5x. Now you'll notice the entire square root is under the radical sign, the 5x, the entire 5x is under the radical sign. So the radicand is 5x. So the derivative with respect to x, I rewrote the square root as the 1/2 power. It's 5 times x to the 1/2 power. Well, you know exponents distribute across multiplication and division. Exponents do not distribute across addition or subtraction. But this is multiplication, 5 times x. So it's the same as asking the derivative with respect to x of 5 to the 1/2 power times x to the 1/2 power. Well, this is a constant number. 5 to the 1/2 power is just a constant number. So it comes out in the front, and we get 5 to the 1/2 power times the derivative with respect to x of x to the 1/2 power. So that's 5 to the 1/2 power times the power rule here. Bring the 1/2 out in the front times x to the 1/2 minus 1. Well, 1/2 minus 1 is 1/2 minus 2 over 2. So it's negative 1/2. Okay, so the 5 to the 1/2 power is the same as the square root of 5. The 2 here is in the bottom, in the denominator, and the x to the negative 1/2 in the denominator is x to the positive 1/2, which we write as the square root. So here, the explanation is that we factored out the square root of 5, and then we took the derivative using the power rule. Now, you'll recall that in our textbook, you'll notice we don't bother rationalizing the denominator, so you didn't have to do anything more on this problem. Now let's look at part 3. The derivative with respect to x of 5x plus the square root of 5x. The derivative distributes across addition and subtraction. So this is a derivative of the first term, 5x, plus a derivative of the second term, the square root of 5x. Well, we already did both of these. The first one, the derivative of 5x, is just equal to 5, and we got that from part 1, plus the derivative of the second term, the square root of 5x, is the square root of 5 over 2 times the square root of x, which we got from part 2. So we didn't have to do anything more, just cite the previous problems, 1 and 2, that we had already performed, and we had already explained it. Let's look at number 4. Find the derivative with respect to x of the square root of 5x plus the square root of 5x. Okay, solution. The derivative, I just rewrote the square root as parenthesis, the 1/2 power. Now I'm going to use the power rule, but I must be careful to use the chain rule because this is a composite function. It's a square root of a function of x. So let's see how we apply the chain rule. First, the power rule, bring the 1/2 out in front, times the base raised to the 1/2 minus 1, which is negative 1/2. And then here's the chain rule right here. You have to hit it with the derivative of the inner function, that's the base, 5x, plus the square root of 5x. Well, that's exactly what we did in part 3. We don't need to do it again. It's already done in part 3, so we'll just use it. We'll bring it down here from part 3. So the final answer for part 4 is 1/2, or I should say 1 over 2 times the square root of 5x plus the square root of 5x. So I just, this negative 1/2 power, I brought it into the denominator to make it the positive 1/2 power. And I also had the 2 down here in the denominator. And I wrote the 1/2 power as a square root. Then I hit it with a chain, citing part 3 as the source. And then finally, the last part, number 5, find the derivative with respect to x of 5x plus the square root of 5x plus the square root of 5x. So it's the square root of all 5x plus the square root of 5x. Well, what do you know? This portion here looks just like part 4. That looks just like part 1. So I'm going to distribute the derivative. It's a derivative of the first plus the derivative of the second. And I rewrote this big square root as a 1/2 power. And after I did the distribution, I said, okay, let's go ahead and evaluate it. The derivative of 5x is 5, citing part 1. The derivative of this mess is this mess, 1/2 big square root of 5x plus 5x times, and this was the chain rule. This all comes from part 4. The second part comes from part 4. 5 plus the square root of 5/2 square root of x. I don't bother simplifying this. This problem is long, and simplifying it isn't going to get me any more points. And there's nothing unsimplified, really. I mean, I just didn't spend any time doing it. All right. So if you did, all right, whatever. I just looked at your early work to see that you were doing what I had done here before you started the simplification process. Okay, now we're going to go to the second part of this quiz number 2. Here is the other part. The first part A says find the derivative with respect to x of the tangent of x. Well, we know by the trig derivative rules that the derivative of tangent is just secant squared. That was an easy one. Part B, find the derivative with respect to x of the sine of the tangent of x. This is a composite function. It's not the sine of x. It's the sine of a function of x. So we have to use a chain rule. So applying the chain rule here, we first take the derivative of the outer function with respect to the inner function. Well, the derivative of a sine is cosine, but it's with respect to the inner function. So it's not the cosine of x, it's the cosine of the tangent of x. And then we have to hit it with the chain rule with the derivative of the inner function tan x, right there. But this is exactly what we did in part A. So I just take the answer from part A, put it here with the multiplication, and I have the cosine of the tan x times the secant squared of x. Okay, that's pretty easy because it relied on the first part. We're going to keep doing that kind of thing. Part C, find the derivative with respect to x of the big square root of the sine of the tangent of x. So here's my composite function under a radical sign. Solution. I'm going to rewrite the square root as the 1/2 power. So this is the derivative with respect to x of the sine of the tangent of x. Well, first of all, I'm going to use the power rule. And I should say that somewhere. Use power rule. Okay. So that means we bring the exponent out to the front times the base, sine of the tan of x, raised to the 1/2 minus 1, which is negative 1/2. And then I hit it with the chain rule since it's a composite function. I take now, see, the outer function is the square root. The inner function is the sine of the tangent of x, which is also a composite function, but we don't have to think that hard. We just calculated this in part B. So we just put the result of part B. So I announced to you here, I'm about to hit it with the chain rule, the derivative of the inner function, the sine of the tangent of x. And then I actually just use the result from part B for this derivative. Here it is here. So I had to bring this part down and I simplified it. I brought the negative 1/2 power to the bottom. I rewrote it as a square root. Okay, so this is the power rule applied here times the derivative of the inner function, all of this, which we got from part B, since we had to use the chain rule, the derivative of the inner function. And finally, part D, find the derivative with respect to x of the cosine of the square root of the sine of the tangent of x. See, I set these up so they would be relying on the previous problem above it, so you don't have to do too much work. First of all, this is a composite function. Well, it's a composite of a composite of a composite, actually. And that would be hard if it was the only thing I asked. But I asked part A, B, C before we got to D to make it easier. So what is the derivative of the outer function with respect to the inner function? Well, the derivative of cosine is negative sine, but this is not cosine x. So this is not negative sine x. It's cosine of this expression. So we start with the derivative of the outer function with respect to the inner function. Then we're going to hit it with a chain. So derivative of cosine of this mess is negative sine of the same mess times the derivative of the inner function, the square root. Okay, but you see the square root, the derivative of the square root is exactly what we did in part C. So I'm taking the entire result from part C and replacing it in place of the derivative. So we have, bring down the negative sign of the square root of sine of tan x. Then we hit it with a chain, referring to part C. This is 1/2 times the square root of sine of the tan x times, in the numerator, the cosine of tan times the secant squared of x. And we are finished.